Hi, this is Mrs. McTaggart, and in this video we're going to look at how to add and subtract fractions. Now there's two different methods to do this. This is a method that I would teach if we are using the approach of finding a common denominator versus what's called the smile and kiss or butterfly or smile and cross method. Before doing this video you should be aware of how to make equivalent fractions. Let's have a little look. So when you've met algebra before, you've probably been told that you can only add letters together that are alike. The same thing happens with fractions. We can only add fractions that are the same. So on the screen here just now, I have got a collection of halves, quarters and eighths. Strictly speaking, right now I can't add them together until I make them into equivalent fractions. So for example, a half we know is the same as 2 quarters. So I can turn my halves into 2 quarters. And then if I would add up all the halves, I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 halves. I could also turn my quarter into eighths. 1 quarter would be the equivalent of 1/8 and do it that way. So you can only add them together by making the denominators equal, by finding what's called the lowest common denominator. So as I said, you should be familiar with equivalent fractions, and lowest common denominator is by finding the lowest common multiple of two numbers. Let's have a look at this in action. So my first example is 3/8 plus 1/2. So one of these fractions is okay at the moment. The 3/8 is alright because if you look at the denominator of the other one, I can actually turn a half into eighths. So remember visually, a half is the same as 2 quarters, which is the same as 4/8. What you're doing is to turn the 2 into 8, you're thinking, right, I'm doing 2 times 4 to make that an 8. And then realise you have to do the exact same thing to the top. Whatever you do to the bottom, you do to the top in a fraction. That's just a general rule. So if I'm multiplying the bottom by 4, I have to do the same to the top. So I do 4 times 1 and I get 4. Now the minute the denominators match, we can add these together. 3/8 add 4/8 collectively, altogether is 7/8. Let's look at another one, this time with a takeaway. So you need to find the lowest common multiple of 3 and 9. Well, it is 9. 9 is in both times tables, so the first one can stay as it is. To turn a 3 into a 9, we need to multiply the bottom number by 3. Hence, we need to times the top number by 3 here as well. So this is the same as 7/9 take away 3/9, which is 4/9. Please don't fall into the trap of subtracting the bottom numbers. They do not change, okay? That's why I say it to yourself. 7/9 take away 3/9. You've still got some ninths left. You've got 4/9 left. Here's another one. So sometimes we have to change both the fractions. So in this one, we're looking for the smallest number in the 4 and the 6 times table. Now, some people might use 24 because 4 times 6 is 24. However, there is a smaller one. They are both in the 12 times table. So 12 is actually the lowest common denominator. And if I wanted to use 24, I could, but I'm just going to have bigger numbers to then deal with. So let's think, how do we turn these into twelfths? Well, 4 times 3 is 12, so I have to times the top number by 3. 3 times 3 is 9. 6 times 2 is 12, so I need to times the top number by 2. So 5 times 2 is 10. And then I just add the top numbers together. 9 twelfths add 10 twelfths is 19 twelfths. Now, there might be the temptation to change this back to a mixed fraction, but I'm telling you right now, this is perfectly acceptable to leave as your answer. It's accepted at National 5 Maths. The only time I would change it back is if they were asking you to find a mixed number. So just out of curiosity, as a mixed number, you would do 19 divided by 12 would be a big 1, and then there would be 7 twelfths left over. So this is the same answer, 1 and 7 twelfths, but I'm telling you 19 over 12 in improper fraction is perfectly okay at this stage. Okay, so my question's going to be a bit trickier now. We're going to involve some whole numbers in here as well. So on this one, we're just going to leave the 4 as it is just now for a wee second and deal with the addition of the two fractions. So we're going to leave the 4 at the front as it is, and we're going to find the lowest common multiple of 4 and 6. Now, I've actually already used these numbers. Lowest common multiple here would be 12. So turn the 4 into 12, we'll multiply by 3. So we're going to do 3 times 3 for the first fraction, which gives us 9 over 12. To turn a 6 into a 12, we're timesing by 2, so we're going to times the top number by 2, making it 10. Now when you add these together, you'll see why this one's a bit trickier. You end up with 4 and 19 over 12. So we need to play about with this a wee bit. I could make it a top-heavy fraction, but it's big numbers. That 19 over 12, that's greater than 1. Okay, so what I'm going to do is I'm going to think 19 divided by 12 is 1 with 7/12 left over. So we're going to take that 1, we're going to add it to the 4. So in terms of whole numbers, we've now got 5 and 7/12 left over. So what I've really got is I've got 4 plus 1 plus 7/12. Putting that together gives me 5 and 7/12. Let's try a couple more like that. This one is a takeaway. This time I've got 2 whole numbers. So we're going to do the whole numbers first. We're going to do big 7 take away big 4, leaving us with a big 3. Then I'm going to find the lowest common multiple of 8 and 3, which would be 24. So to turn an 8 into 24, we times by 3. So I times the top number by 3, making it 21 out of 24. To turn the thirds into 24, well, I need to times by 8. So I times the top number by 8, giving me 16. And then I can just subtract the top numbers. 21 take away 16 is 5. So my answer is 3 and 5/24. If that's even a word. 3 and 5 over 24. Let's look at another one. Okay, this is going to be another one of those wee addition ones where it carries over. So we're going to do the big 2 plus the big 3, which gives us a big 5. We're going to think, what can we turn halves and thirds into? Well, the lowest common multiple of 2 and 3 is 6. I can turn them both into a 6. So 2 times 3 is 6, so we'll times the top number by 3. So 3 times 1 is 3. To turn a 3 into 6, we're timesing by 2. So we're going to do 2 times 2 on the top, which is 4. And this will give us 5 and 7/6. Now remember, it's 7 over 6. 7 divided by 6 is 1 remainder 1, so that's 1 and 1/6. So I've really got 5 plus 1, which will give us a big 6 and 1/6 left over. Okay. So that's me covered 2 lessons in one so far. What I haven't covered is the subtraction ones where it gets so tricky. So I call these tricky subtractions. By this, what I mean is you're going to end up with a bigger number to take away than what you actually have available. So this is going to be my first tricky subtraction, and this will hopefully lead you into a skill you need at the end of some of the harder ones to come. I always like to draw a little picture of this one, so I like to talk about cakes. So if you had 4 cakes, okay, and someone eats 3 of them, those 3 have now gone, okay? And then if I cut this cake into fifths very badly, and someone eats 3 of those fifths, can you see that you're just left with 2/5? So I can't always draw this visually, but what I did there was I essentially did 4 take away 3 left me with 1. And then that left me with that 1 full cake, remember? Then I took away 3/5 from that. And what I did is I turned that full cake into fifths. So I made that full cake 5/5, take away 3/5, which left me with 2/5. Now, some pupils can just look at this and see it. Some people need a wee bit of help and maybe some extra steps in there. But essentially what I'm going to do is I'm going to try and go straight from this step to this step if I can on these next examples, okay? So let's have a look at this in action. We're still going to do what we're doing. There is always the option to make these top heavy, by the way, at this point if you wanted. And that would avoid it. What I might do is do this one in 2 different ways. But we're going to stick with the method we've been doing. Whole numbers first. So 5 take away 1 is 4. And then what can I turn fifths and halves into? Well, I'm going to turn them both into tenths because that is the lowest common multiple of 5 and 2. So 2/5, I need to double that one, would become 4/10. 1/2 I need to times by 5, which would give me 5/10. Okay, so I can't do 4 and 4/10 take away 5/10 because I can't take 5 away from the 4. So we've got some options. What I can do is I can think, well, 4 take away 5 is -1. So I'm left with a big 4, take away 1/10. Now, to take 1/10 away from 4, I'm going to go into 3. So think about it. If you had 4 cakes and I take a little bit out of one of them, you've now only got 3 full cakes, yeah? And there would be 9/10 left there. So I've got 3 and 9/10. If this is a wee bit tricky for you, the alternative is you can think of it as like borrowing. So I could think of that 4, I could turn that into 3 and turn 1 whole into 10 tenths. And my sum could become 3 and 3 tenths take away 1 tenth, which takes me back to the 9 tenths. Or if you get to the point where you just find it's all a little bit too much, we could make them improper fractions. 5 times 5 is 25 plus 2 is 27. So I can go and do 27 over 5, take away 1 times 2 is 2, add on the 1 is 3. So I can make them into improper fractions, like that. Then I can turn them into tenths. This one would be doubled, this one would be multiplied by 5, which gives me 54 take away 15. And 54 take away 15 would give me 39 over 10. And remember, 39 over 10 is the exact same as that answer there. So you can always turn them into improper fractions if you wanted to. But I'm doing this method as dealing with the whole numbers first. So that's the way I'm going to do the rest of the examples. Okay, here's another one, another tricky subtraction. So big 4 take away big 2 is 2. Eighths and fifths, well, what can they both go into? Well, they can both turn into 40. 8 times 5 is 40, so I do 3 times 5 is 15. 5 times 8 is 40, so I do 3 times 8 is 24. So I can't really do that. So 15 take away 24 is negative 9. So I'm left with 2 take away 9 40ths. If I take away 9 40ths, that's going to eat into the 2 and leave me with 1 whole. And then 40 40ths, if you want to think of it as that, is 1 and 40 40ths. Take away 9 40ths, you can. And that'll give you 1 and 31 over 40 left over. Numbers are getting a wee bit bigger now. So it's okay to go straight from here to this line if you can, brilliant. If you need to think of it as exchanging, you can. There's just so many methods, that's the unfortunate side to this. Okay, for my final example, I'll just do one more like those tricky subtractions. So I'm going to do big 6 take away big 3 is 3. Fifths and quarters, well, the smallest number, the 5 and 4, both go into is 20. I need to multiply this one by 4 because 5 times 4 is 20, so I've got 8. I need to multiply the second one by 5 because 5 times 4 is 20, so that will be 15. This leaves me with 3 take away 7 20ths because 8 take away 5 is 7. Sorry, 8 take away 15 is minus 7. And then taking away 7 20ths, I'll eat into the 3, leaving me 2 full or 2 whole cakes. I like to talk about cakes. If you take 7 out of 20 away, you're left with 13 out of 20. And remember again, you might want to think of that as 3 and 20 20ths. Take away 7 20ths if that helps.